अऊज़ु बिल्लाहि मिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम। पनाह मांगता हूँ मैं अल्लाह की शैतान मरदूद से। अल्लाह के नाम से शुरू जो बहुत मेहरबान निहायत रहम वाला है। I welcome you all in the online lab of ECD, Electronic Devices and Circuit. Hope you all are fine and having good health. Today we have started the Lab-9 Widlar Current Source Lab, and the objective of today's lab is to illustrate the operation of two BJT constant current source, Widlar current source. So if you have any kind of query in previous labs, feel free to discuss. I will resolve your queries, your issues in this lab online session. And if you have not any kind of issue, we continue today's session. Okay, after the objective comes to the introduction of this lab. A Widlar current source is a modification of the basic two transistor, and these transistors are BJT, not MOSFET. Categorically, we are conduct lab on BJT transistors and as well on MOSFET transistors. Previous lab that we have discussed about the Widson current mirrored circuit. In the previous lab 8 was on Widlar current mirrored circuit, and today's lab in the topic of Widlar current source based on the transistor BJT 2N 2222 is the transistor. Already I have done the simulation in multisim. Okay, again come to the introduction. A Widlar current source is a modification of basic two-transistor current mirror that incorporates an emitter degeneration transistor for only the output transistor, enabling the current source to generate low current using only moderate resistor values. By placing a resistor in series with the emitter in BJT, one of the two transistors of the current mirror, one of the two transistor in current mirror, the base emitter voltage. In between the base emitter voltage, the current mirror is already formed. What is the meaning of current mirror? Anyone have idea about current mirror? So explain if you have idea about current mirror. uh, Student, if you have idea about current mirror, which I already incorporated in previous lab 8, so tell me if you have idea about current mirror. Current mirror circuit is a kind of circuit in which the source of current exact equal to the load current but opposite end sign, having the current gain of -1. In previous session we already discussed these kind of information, so it is a request with all of you that you all have to see, observe and understand the previous lab sessions, so categorically you are ready to understand the upcoming labs which I discuss in these and future weeks also. Source of generated low currents using only moderate resistor values. By placing a resistor in series with the emitter of one of the two transistors of a current mirror, the base emitter voltages are no longer the same and the currents through the two transistors are scaled relative to one other. One other means, if you see the simulation, you can understand that one is transistor is opposite to the other one. The current mirror is formed in this scenario. This is the principle of Widlar current source, in which the reference current can be either scaled down or scale up. Both options will be examined in this procedure. that we discuss here, it is the same circuit that we discuss in lab 8, but the difference is we have performed the practical on MOSFET transistor, but here we discuss the experiment with BJT transistor. If you can see, we provide the source of voltage with the reference current, that is the input current here, and we get the output at this stage or in the form of output current. The input current and output current are same in magnitude, but with a difference of sign. And this scheme that we studied here is the Widlar current mirrored circuit formed by the BJT transistor. This is the principle of Widlar current source in which reference current can be either scaled down, means that we provide the supply from this and the output current can be opposite in direction and will be scaled down, or scale up. That means can be scaled up and can be scaled down by the circuit. Both options will be examined in this procedure. The same scenario of the circuit I already incorporated in the simulation in this form. So it is another request with you that you all have to install Multisim. The link I already shared with you on our WhatsApp official group of PG and ECD, by which most of the students are make their own circuits and share with me and perform their task on time. So it is a duty with all of you, to all of you, that you perform all the kind of these tasks and practice more and more. That's the reason you will explain all the kind of things in final exam of ECD lab exam. In the above circuit of 8.1 is the example of Widlar current source using bipolar transistor, where the emitter R3 is connected in series. Emitter is connected in R3 with series. Here is the Q2 R3 connected with emitter. If I think you all know that this is the gate, this is collector. I mean, sorry, base, collector, and emitter. And in this transistor of Q2, another resistance of R3 is connected in series with this transistor, which is discussing at this level, where the emitter resistor R3 is connected in series with the emitter of output transistor Q2. Here we already seen this, and has the effect of reducing the current in Q2. So by this way, that reducing current would be happened. Relative to Q1, the key to this circuit is that the voltage drop across the resistor R3, because it is series in Q2, the automatically the upcoming voltage can be divided at this level and also in this level, because transistor and resistor are connected in series scheme. So voltage would be divided. Comes to the next thing, that and has the effect of reducing the current in Q2 relative to Q1. Q2 relative current would be dropped at the state of Q1 because R3 is also connected in series with Q2. The key to this circuit is that the voltage drop across the resistor R3 subtracts from the VBE, that is base to emitter junction voltage of transistor Q2, thereby reducing the collector current compared to transistor Q1. So we can compare the current of Q1 with Q2 at this stage of level. Similarly, the reference current would also be found from the formula that we already incorporated in the theory classes. The reference current IRF is given by the IRF equal to VCC, that is the common source voltages, minus VBE, the junction voltages, divided by the R2 resistance. That by this formula we can extract and get the value of I reference. I reference is the input or supply current from the source side. Up till now, if any kind of query is in your mind, you can feel free to ask. I will answer you all kind of queries, questions. You can ask kind of queries if you have. Otherwise, we can continue the session. The reference current I naught in figure 9.1 is given by I naught into R2. Vt into ln reference divided by I naught. This is the same formula. R can be divided from this level and we can get the I naught, that is the output current. Moreover, another important characteristics of the Widlar current source is that its output resistance is high. Another aspect of this Widlar current source circuit is that its output resistance is high. Similarly, in the previous lab, we already discussed the mirror circuit, that the output resistance was mirror circuit was high and the input resistance is low. Same scenario can be happened in this level that we already discussed in MOSFET circuit of mirror circuit, and here we're discussing in Widlar BJT based circuit, that is the mirror circuit as well. The increase in the output resistance above the achieved in the basic current source is due to the emitter degeneration resistance of RE, that is the emitter resistance, degeneration resistance. The output resistance of Widlar current source is given by output resistance can also be found. And what is the output resistance? This is the output resistance at which the mirror circuit get the output resistance is high as compared to the input resistance, because it is a feature of mirror circuit that we got the higher resistance in the output side of mirror circuit, that is incorporated here. R not equal to 1 plus gm is the transconductance of the circuit, and the concept of transconductance we already incorporate in our previous circuits. Transconductance is similar to the conductance and it is a reciprocal of resistance. Okay, the multiplied the transconductance into Re, that is parallel with R pi multiplied by the R naught. This formula is also incorporated in lab 7. We already discussed in previous labs. Comes to the circuit. Thus the output resistance is increased above R naught by a factor that can be significant. Here is the complete circuit of today's lab that I already incorporate in multisim simulation. These are the source of 10 volt supplied by this level, R1 and R2 with the resistances, two BJT transistors. Bases can be derived by the source after resistance categorically is this level, and the Q2 is connected with the resistance to ground and Q1 directly ground. This resistance is connected to vary the current and limit the current at Q2 side, and Q1 side is without limit to ground. Comes to that, this is the procedure that design a Widlar current source that produces an output current of approximate equal to 10 microampere. This is the output current that we extract or get from the Widlar current source output circuit, while the keeping reference current of 1 milliampere, and the input current reference current would be in milliampere of 1, and the output current would be 10 microampere. Determine the value of R2 R3 using equation 9.2 and 9.3. 9.2 9.3 equations are here. By this level you can get the output resistances. Construct the circuit as shown in this figure 9.2, that is here. I already make it on multisim simulation using the value of R2 and R3 closest to the value determined mathematically in step 2. That means we have to find the resistance value R2 and R3. Note that current reference of I reference at I naught using digital multimeter and fill the observation table 1. So there are two tasks that have to be done in this simulation of circuit, that we have to find R2 and R3 resistances and I reference and I naught. That means input current and output current that we have to find in these labs. This is the reference current, that is desired value is 1 milliampere and output desired value is 10 milliampere, 10 microampere, sorry. Practical value can be extracted from the simulation and simulated results that we already done in multisim simulation. And these are the further tasks of which are incorporated here. So I'm going to measure the resistances and the output. Here is only the output and input current column that we have to find. So comes to is in this level and have to find the input and output current. So for this purpose, how can I measure the input and output current? Can anyone tell me that how can I measure input and output current? Anyone have idea that how can I measure the input and output current? No one have idea that how can I measure the current? Acha, okay, tell me one thing that how can I measure current? What kind of instrument that I'm going to use to measure the current? Can anyone tell me? Okay, uh, the instrument is multimeter. Multimeter is a device which is used to measure the current, and we have to find the input and output current. For this scenario, we have to connect a circuit that is here. Up till now, if anyone have any kind of query, please feel free to discuss. I will resolve your query and answer your questions. If you have any kind of question, please feel free to ask. I will answer your question. And here I am going to measure the current. Up till now in simulation or in lab theory, if any person have any kind of query, please feel free to discuss in this online interactive session. I will resolve your query. Hopefully no one have any kind of query that I am discussing at this level. Okay, comes to the simulation. First we have to maintain the current, that is ampere and DC, and this is the ampere in DC, and simulate the kind of results. So automatically that I said to you is a mirror circuit and provide the output. This is in milliampere and this is in microampere. So this is the way that how to measure the kind of ampere. So in practical scenario, practical result is same as the simulated result. There is a slight difference between these two things. So simulated result, that is I reference, would be 1 milliampere desired value, and we got in simulated results that I reference. What is I reference? This is I reference. Minus sign is because of the opposite connection, because positive would be here and negative would be here. Due to this connection, we got the negative sign. So the value is 9.3 milliampere. This is the simulated result. Desired is 1 milliampere and we got the 9.3 milliampere in simulation result. And moreover, at the output current is 10 microampere. This is the desired value, and the simulated result that we got here is 100 uh, 22.5 microampere. This is the output current that we measured at this level. So up till now, if anyone have any kind of query, please feel free to discuss. I will answer your questions. Anyone have any kind of difficulty, any kind of issue, please feel free to discuss. I will resolve your query. What is the advantage of Widlar current source? So these are the questions that you have to answer here. If you listen and understand my theoretical aspects, which I already discuss with all of you in the starting towards ending of this lab. You already answer this question. Okay, comes to that. Furthermore, this is the simulation and result that is end here. Up till now, if anyone have any kind of query, please feel free to discuss. I will resolve your kind of queries. Otherwise, I am sharing this simulation in our official group. Anyone have any kind of query, please feel free to discuss. I will resolve your query. Students, uh, someone said no, sir. Okay, it's a simple lab, and you already incorporate here. And I'm going to share this snap with our official group. Uh, mm, there you go. So this is the end of today's lab, and now we have to start the next lab, that is lab number 10. Up till now, if anyone have any kind of issue and difficulty, please feel free to discuss. And now we end this lab session, and in another session I'm going to discuss the lab number 10 by the same link which I already share with you in our WhatsApp group. So also join by the same link. I again continue the lab session of lab 10. So it is requested with you to join this lab same as before. So till now I end this lab session. Thank you.